Hello students, welcome to physics class. Today we discuss the first law of Newton and inertia. In the last session we discussed the Galileo law of inertia. Sir Isaac Newton studied the motion and extended the Galileo law of inertia. He proposed the three laws related to the motion and known as Newton's laws of motion. Today we discuss the first law of Newton. Let us see what is the first law of Newton. Actually, the first law of Newton is nothing but the Galileo law of inertia itself. That is, according to the first law of Newton, the Newton's first law states that every body continues in its state of rest or of uniform motion in a straight line unless it is compelled by some external force to change that state. Actually, it has three sections. We can discuss the concept of Newton's first law of motion, dividing this statement by three sections. That is, the first section, every body continue its state of rest unless it is acted by an external force. It means that if a body is at rest, it will be ever at rest unless it is acted by some external force. If no force is acting on the object, it will be continue its state of rest. The second case, if the object is in uniform motion, suppose if an object is in motion, if there is no external force acting on the object, that is, the net force acting on the object is zero, then the body will continue in motion. The third case is, suppose the body is in a straight line motion. If there is no external force acting on the body, it will be continue its straight line motion unless some external force is acting on the body. So that is the Newton's first law. Actually, it introduces one of the property of the body, that's the inertia of the body, that every body having some inertia. According to Newton, the inherent property of a body by virtue of which it cannot change by itself its state of rest or uniform motion in a straight line is called inertia. The first law of Newton defined the term inertia like that. So the first law of Newton is also known as the law of inertia. The inertia is actually the property of a body, that the body have a tendency to continue its state. If it is at rest, it have a tendency to continue at rest. If it is in motion, it have a tendency to continue in motion. If it is moving along a straight line, it have a tendency to continue in the straight line. That tendency of the body or the inability of a body to change the state by itself is known as inertia. Every body having some inertia. Now see, there are different types of inertia. Out of this, inertia of rest. One of the inertia is inertia of rest. The tendency of a body to remain in its state of rest is called inertia of rest. Suppose if a body is at rest, it have a tendency to continue its state of rest. That tendency is known as inertia of rest. The tendency of a body to remain in its state of rest is called inertia of rest. For example, a person standing in a bus falls backward when the bus suddenly starts moving. Suppose if a bus is at rest, a person is standing in the bus. If the bus suddenly starts in forward direction, the passenger or the person that standing in the bus fall backward. This is just because of that When the bus is at rest, the passenger is at rest. When the bus suddenly start moving, the lower part of the body, which is in contact with the bus, move first. But the upper part of the body is not moving. It have a tendency to be at rest there. So when the lower part of the body is only in motion, the upper part fall backward. That's why the passenger fall backward when a stationary bus start suddenly. The second example, the dust is removed from a hanging carpet by beating it. Usually, to remove the dust from a carpet, we are taking the carpet, we are hanging the carpet and beating it. When you are beating, the carpet is moving, but the dust particle having a tendency to be at rest. So they cannot stand there, so they are falling down. The third example, a coin fall into a tumbler when card is given a sudden jerk. Suppose we are keeping a cardboard on a tumbler like this. Suppose this is a tumbler and a cardboard is kept on the tumbler. And if you are placing a coin here, and suddenly if you are giving a jerk to this cardboard or just a flick in the cardboard, suddenly you can see that the cardboard may fly away, but the coin is falling to the tumbler. This is also because of the inertia of rust, that this coin having a tendency to rust, but the cardboard is moving, so the coin is falling to the glass tumbler. And one more example, when we shake the branch of a tree, its fruit and dry leaves falls down. It is also due to the inertia of rust. When we are vigorously shake the branch of a tree, the branches are moving, but the tendency of the fruit and the leaves is to stay there, to continue its state of rest. But it cannot be there because the branch is moving, so they get fall. Now see the inertia of motion. The tendency of a body to remain in its state of uniform motion in a straight line is called inertia of motion. If the body is in motion, the body has a tendency to continue in the state of motion. That is, the every body having a tendency to remain in a state of uniform motion in a straight line is called its inertia of motion. Example, when a moving bus suddenly stops, a person sitting in it fall forward. Suppose a passenger is sitting in a moving bus. Okay, the bus and passengers are in motion, both having a tendency to continue in motion, but the bus stopped suddenly. So what happened is that the passenger having a tendency to continue his motion, but what happened, his lower part of the body suddenly stopped along with the bus, but the upper part of the body continue the motion and he fall forward direction. Another example, an athlete run for a certain distance before taking a long jump. During the athletic meet, you may be noticed that those who are taking a long jump run certain distance before he taking the jump. That when he run certain distance, he gains some inertia of motion, and it gives some muscular effort to his body. And with that muscular effort, he can jump more distance. He can cover more distance during the jump. The third example, a person getting out of a moving bus or train fall in the forward direction. That is, when he suddenly jump out of a bus or moving train, he have a tendency to continue the state of motion because the bus or train was in motion. When suddenly come out of this bus or train, the lower part of the body, which comes in contact with the ground, suddenly stops. But upper part of the body have a tendency to continue the motion. That's why he or she may fall down when he jump out of a moving bus. The next type of inertia is the inertia of direction. The inability of a body to change by itself its direction of motion is called inertia of direction. That if a body is moving along a straight line, it have a tendency to continue in a straight line motion. It cannot change the direction by itself. Some example, when a bus takes a sharp turn, a person sitting in the bus experiences a force acting away from the center of the curved path. Suppose when we are traveling in a bus, when the bus taking a sharp turn, up to that the bus was in a straight line motion. When the bus taking a sharp turn, everyone, that's the bus and the passengers, having a tendency to continue in a straight line motions. So when the bus takes a sharp turn, the person sitting in the bus experience a force acting away from the center of the curved path because of this inertia of direction. The second example, during the sharp, okay, during the sharpening of a knife, the sparks coming from the grindstone fly off tangentially. This is also because of the inertia of direction. Third example, when a vehicle moves, the mud sticking to it, the wheels flies off tangentially. That is, when a vehicle move, you may be noticed that the mud sticking to its wheels, the flies off tangentially because of this inertia of directions. Now let us see what decide the inertia of a body. The inertia of a body is decided by the mass of the body. So we can generally say mass is the measure of inertia of a body. Mass is the measure of inertia of a body. That is, mass and inertia are directly proportional. If a body has more mass, it has more inertia. If a body has more mass, it has more inertia. It means it is more difficult to change its state of rest or of uniform motion. If you are saying a body having more mass or more inertia, it is difficult to change its state of rest or uniform motion. Example, if we kick a football and a stone of same size, we can see that the football flies a long way, but the stone of almost the same size hardly move. The reason is that if you are comparing the stone and football, even though the size are same, stone is much heavier than the football. So it having more inertia and it flies or it very hardly move. But the football having less inertia comparing to the stone, so it flies a long way. That about inertia. That's all today. Thank you.